We are moving past the era of prompt-driven generative AI. The industry is moving from stateless programs that wait for specific instructions to stateful, autonomous systems capable of reasoning through and executing multi-step goals. Traditional AI functions as a discrete tool. You ask a question, it generates a response, and the process ends. Agentic AI operates continuously in the background. It anticipates needs, accesses external databases, and adjusts to errors as an active team member. Over the next 3 years, autonomous agents are projected to generate up to $450 billion in economic value. 14% of organizations are already implementing these systems at scale, an adoption rate mirroring the 2023 surge in generative AI. Agentic AI is no longer a theoretical research paper. It is an active structural transition in enterprise architecture that is already well underway. But this rapid adoption masks a central paradox. Despite financial incentives, enterprise expectations for these systems to operate independently remain strictly capped. To understand why, we have to quantify what AI agency actually means. We can measure this using a 6-level autonomy framework, adapted from how the automotive industry categorizes self-driving vehicles, stretching from level 0 to level 5. We use this framework as a diagnostic tool, allowing us to pinpoint exactly where the enterprise market is technically capable and where it is operationally stuck. Moving up that scale requires dissecting the specific technical architecture required at each of these 6 steps. Capturing that $450 billion does not depend on raw computing power alone. It depends on an organization's ability to safely navigate this autonomy scale. As the slider advances to levels 1 and 2, we enter the baseline of current AI. Level 1 is AI-assisted, and Level 2 is AI-augmented. The architecture here is a straightforward prompt-to-output loop, connected only to isolated internal data. The operational reality of these levels is high human involvement. The AI supports decision-making and provides recommendations, but it strictly requires an explicit user trigger to initiate any action. The technical limitation here is structural. These systems rely on basic reasoning models and are walled off within closed internal data environments, incapable of real-time external interaction or long-horizon planning. These tools boost individual productivity by summarizing documents or generating code, but they cannot manage an end-to-end workflow independently. Levels 1 and 2 are sophisticated assistants, but their performance remains permanently gated by their reliance on continuous human prompting. The critical structural leap happens when we finally cross the chasm to reach Level 3, semi-autonomous or process-centric AI. Level 3 architecture requires new components: agent-to-agent protocols for models to collaborate, and the model context protocol to access external tools. This introduces the orchestrator model, which breaks a complex goal down, distributes subtasks, and iterates continuously until the goal is achieved. Multi-agent orchestration has been a theoretical concept for years. Why is it only becoming scalable right now? Looking at this graph, the catalyst is clear. Inference costs for benchmark models have collapsed, dropping over 100-fold in just the last 2 years. And while costs plummeted, model capabilities for long-horizon reasoning exploded, doubling roughly every 213 days. This collapse in computing costs changes the enterprise math. Running continuous, multi-agent reasoning loops in the background is now financially viable for the first time. This brings us to the frontier. Level 4 is independent operation. Humans delegate full execution authority within predefined strategic boundaries, relying on heavy operational guardrails while retaining emergency oversight. Level 5 is fully autonomous execution. Human involvement is restricted purely to initial goal setting and post-execution compliance monitoring. But the deployment reality lags the technical capability. This chart shows that today, organizations expect only 15% of their business processes to operate at Level 3 or higher. Looking out to 2028, expectations for Level 5 autonomy reach just 4%. Even with a 3-year runway, enterprise projections for full Level 5 automation remain in the single digits. Organizations have the architectural blueprints. The compute costs are viable. But the enterprise market is colliding with a hard, non-technical barrier. The critical bottleneck preventing the scaling of Level 4 and 5 systems is a growing enterprise trust deficit. The survey data is explicit. Currently, 60% of organizations report that they do not fully trust AI agents to manage tasks autonomously. More concerning is the trajectory. Over the last 12 months, trust in fully autonomous agents dropped from 43% to 27%. This distrust stems from specific causes: ethical vulnerabilities, poor data readiness, the black box nature of AI, and unchecked algorithmic bias. Technological capability has outpaced organizational confidence. Before these systems can scale, organizations must establish robust and explainable guardrails. To mitigate this risk, the enterprise market is shifting how it procures agentic architecture. 62% of organizations are choosing to partner with existing solution providers and system integrators, moving away from building proprietary, high-autonomy agents entirely in-house. Partnering allows businesses to outsource the risk, providing pre-built guardrails and standardized compliance protocols that integrate with their existing IT systems. For IT leaders, the mandate is clear. Workflows must be redesigned for human-AI collaboration. The goal is integrating an adaptive team member, not deploying a total human replacement. Capturing the projected $450 billion in value requires absolute transparency. Organizations must establish trust through secure execution at level 3 before they can realistically scale to level 5.